Okay, and we're back, people at our home. So again, what we said here, I'm not sure where this thing kicked off at. I'm going to repeat myself a little bit here. That when we times, we add, so the log of 5 times 3 is the same as the log of 5 plus the log of 3. Or working backwards, the log of 2 plus the log of 6, when we add, we times, you get log of 2 times 6, which is 12. The quotient rule, when you divide, you subtract. The log of A over B equals the log of A minus the log of B. An example would be this. If I gave you the log of 7/4, that would be the same as, let's write this as 2 logs, okay? That'd be the log of 7, and be careful here. Some students say, so it's the log of 7 minus 4? No, not the log of 7 minus 4, the log of 7 minus the log of 4. Okay, you need to write the word log twice, okay? All right, we're expanding it. Went from 1 log to 2 logs, okay? Let's go from 2 logs to 1 log. What if I said the log of, and let's simplify this as much as possible. What's the log of 20 minus the log of 5? What would that be the same as? Log of 20, take away the log of 5, would be the log of
15.
Careful, when you subtract, you what?
Divide.
You subtracted. It's not 15. Log of,
20 over 5.
which is what? Don't keep saying 20 over 5. I did that last time. 4. Again, where'd 4 come from? 20 divided by 5, which is 4. Okay? Third rule is the power rule. Okay? And I want somebody to just very simply, this is not a math question here, okay? I'm going to write what the rule is. Then I seriously want everyday language, okay? Just everyday language, okay? It's not a trick question. Because the way I explain it's an everyday language anyhow, okay? The power rule says this. The log of A to the n power is the same as that. Okay? The power rule. So what do I do? And let's make it real simple. When do you use the power rule?
Just
When you see a
split them apart.
when you see a power. And what do I do? What do I do with that power?
Separated.
Separate it how?
On each
Who said
side
that?
of the log.
I put it at the front. If it's in the front, you know what you could do it if it's in the front? You move to the back. Okay? So an example would be this. If I gave you the log of x to the 4th, that's the same as what? 4 times, and what does 4 log x mean? 4 plus log x? 4 minus 4 what? 4 times. That's the same as 4 log x. 4 times the log of x. And again, I already said this earlier, I'm going to say it again. I haven't been putting bases down, okay? So they're all base 10, which is a common log, okay? So, I mean, it doesn't matter. I can make all these bases 7s, or I can make them all 3s. It doesn't matter, okay? All right, so let's work on another one, then let's start the assignment, okay? How about 7 log w? What's that the same as? 7 log w is the same as log w what? W to the 7th power. You can move it out front, you can move it back to a power. It works both ways. Okay? Questions on these? Okay, you're going to use these notes on the entire assignment, okay? I'm going to write up front with you guys here. I don't like the way they start out this assignment, okay? To me, it starts out really tough, kind of confusing, and then it gets a little bit easier. I wish they would put the problems at the beginning, at the end, but it's not that many questions, okay? So, let's look at exercise number 3. Problem number 3. They give you some information here, okay? They give you a log base 7 of 4, log base 7 of 12. Log base 7 of 4, log base 7 of 12. You guys know what these little wavy lines mean? Approximately equal to, okay? 0.712 and what? 1.277. Okay, now don't worry about where they got these approximate. They use a calculator, okay? That would be definitely something you use a calculator. Now, you should be able to tell me this, though. We've had a day off, so if you can't, it's not the end of the world. But how would you know that the log base 7 of 12 has got to be bigger than 1? I mean, it's 1.2. How would I know it's definitely bigger than 1? Any idea? That the log base 7 of 12 has got to be bigger than 1. Well, what's the log base 7 of 7? 1. Why? And don't say times. 7
to the first.
to the first power is 7. So log base 7 of 12's got to be more than that, okay? So that's how they get that. That's why this is less than 1, okay? And again, you would use a calculator, and you don't even know how to punch it in a calculator yet. You only know how to do log base 10 and log base E on a calculator. Okay, we'll show you later how to type these in a calculator. So using that information for the next few problems, they ask us to find the log base 7 of 3. Okay, and I'm not making fun here, but we're going to rely on mathematics that you learned in elementary school, literally elementary school, okay? They give you the log base 7 of 4, they give us the log base 7 of 12, okay? I want the log base 7 of 3. So here's what you need to look at. I got all this stuff up here. There's only 3 things you need to be looking at. You need to look at the 4 and the 12 and the 3 right here, okay? I want 3. Using the numbers 4 and 12, how do you come up with a 3 using the numbers 4 and 12? What divided by what? Okay, so that's the log base 7 of 12 over 4. Okay? Now, listen carefully, because this is a very simple response. If you can't answer, it's okay, but after we say it, you'll be like, oh man, I can't believe I didn't say that, okay? Which property are we going to use on this particular problem? Number 1, number 2, or number 3? And why?
2.
2. Why?
Because there's quotients.
And quotient means what?
Fractions.
The fractions mean dividing. We're dividing. You're not wrong, okay? We're dividing. When you're dividing, you use this one. And when you divide, you what? Subtract. So that's the same as the log base 7 of 12 minus the log base 7 of 4. Jot that down. I would really encourage you to show your work on these, okay? Now what do we do? I mean, yeah, we wrote the log base 7 of 12 minus the log base 7 of 4. How do we find, this is sort of a trick question here, what's the easiest way to find out what the log base 7 of 12 is? Sort of a trick question. What? Do you know what the log base 7 of 12 is? You don't? Oh, that's what I mean. Do you know approximately what the log base 7 of 12 is? What? How do you know that? It says so. They told you the log base 7 of 12 is about 1.277. Minus, what's the easiest way to find the log base 7 of 4? It's right there, 0.712. And we simply subtract them. We simply take 1.277 minus 0.712. We do that, we get 5, 0.545? 1256. No, that's not right. 56. 0.565? 0.565, and there we go. Now, I want to make sure you understand, this problem's done. This problem's done, okay? Could I have said the log base 7 of 3 is the same as the log base 7 of 21 divided by 7? Could I have done that? Not a trick question. Could I have done that? Log base 7 of 3 is log base 7 of 21 sevenths? What's 21 divided by 7? 3. So could I have done that? Sure, I could have. You know why I didn't? If I did that, that'd be the log base 7 of 21 minus the log base 7 of 7. You're still up. What's the log base 7 of 21? How come? How come you knew this? Because they told you, okay? You want to come up with 3 using the numbers that they give you, okay? I came up with 3 here, but they didn't give us these. Now, I do know the log base 7 of 7. It's 1, okay? But the other one, I have no idea what it is. Okay, let's try another one. We're going to use this information on the next several problems, okay? Question number 5. Okay, I want the log base 7 of 16. There's at least 2 ways you could do this question, okay? Again, we're using these. How do I come up with a 16 using 4 and 12? This is sort of a tricky one. Ooh, this is a tricky one, okay?
Add.
Product, what do you mean? So what times what?
It's not, or the log base 7 of 4
not careful, okay? Forget all the logs. Just forget those, okay? Forget those right now. All I'm asking is, using a 4 and a 12, this is where it gets tricky. Oh, this is a tricky one. Jeez. I think you're making that mistake. To come up with a 16 using a 4 and 12, now here's the deal, okay? 4 plus 12, 16. And that's where you went. I'm not going to disagree with you, okay? What I should have been saying is this. How do you come up with a 16 using 4 and 12, but you only get to do 3 ways? Product, which means multiply. Quotient means division. And power means the next one, okay? So how do I come up with 16 by multiplying or dividing or using a power? Using a 4. Now again, you don't have to use a 4 and a 12. Just 4 or 12 or both.
4 times 4.
Or 4 what?
Squared.
So you said 4 times 4. Which one would you use? 1, 2, or 3?
1.
Why? Because you're what? You're
Do times
timesing. Then you also said 4 what?
to power.
So which one would you use then?
Power.
Which is the right way?
Both.
Do you have to do both?
No.
No. What do you want to do? 4 times 4?
Oh, yeah.
Okay. So what we're going to say here is the log base 7 of 4 times 4, which is the same as the log base 7 of 4 plus the log base 7 of 4. Actually, I'm kind of glad Phoenix said that, okay? He's totally right when I said, how do you come up with a 16 using a 12 and a 4? He said you add them together. He's not wrong, okay? What I should have said was, how do you come up with a 12? I'm sorry, how do you come up with a 16 using a 12 and a 4, but you have to either multiply or divide or do a power. And Chelsea said you can either multiply or do a power, it doesn't matter, okay? Log base 7 of 4 is 0.712 plus 0.712. Do that, we get 1.424. Okay, I'm going to erase these. I really hope you guys wrote them down. We're going to spend at least 3 days on this section, okay? This is not an easy section. All right, number 7. How many of these do we have? Yeah, we're almost done with these types. Yeah, only one more of these. Okay, log base 7 of, what does that say? 1/4. This is a tricky one. Log base 7 of 1/4. This is a tricky one, okay? Now I need to come up with 1/4 using a 4 and a 12. This one's a real tough one to see, okay? Any thoughts on this one? How to come up with a 1? I mean, we have a 1 on top. There's no 1 here, okay? Here's what you're going to do. This 4 has an exponent, it's a 1. I'm going to move that 4 to the first on top. And it comes 4 to the negative first. 4 to the negative first is the same as 1/4. Which property do you think I'm going to use? Why? We're dealing with the power, dealing with an exponent. What can I do with that negative 1? So negative 1 times the log base 7 of 4. So negative 1 times, what's log base 7 of 4? 0.712. And negative 1 times 0.712 is negative 0.712. That's a tougher one. It's not as obvious. Okay. Let's move on to number 9. Let's get into, I think, easier ones. These are okay, but the next ones, what we're doing from this point forward is much more important, okay? What they want you to do is write these as one log. And part of these questions I don't like, okay? And you'll see why on this very first question, okay? I'm not saying it's just, we'll talk about it here in a second. Log base 3 of 6 minus log base 3 of 2. Okay? Now, if I was asking this question, I would say simplify this as much as possible. That's not what they want you to do. They want you to write it just as one log. Write it as one log, okay? So, what property are we going to use? We're going to use the product rule or the quotient rule or the power rule on this one.
Power.
Do you see powers up there or not? Where?
6 and 2.
Those aren't powers. That's our base, that's a number. If it was like 6 to the 7th or something like that, that's not a power, okay? Be careful, that's not 3 to the 6th. Okay, remember when I told you how you got to write this a couple weeks ago? You got to write these correctly. Don't, if I wrote it like this, then it is. What's my base here that you don't see? 10, but it's not. It's base 3 of 6. Okay, now you could say there's a power there. It's a 1, but if you move the 1 out front, nothing happens. Yes, ma'am. Why? You're right. Why? When you subtract, you're what? Dividing. Now watch carefully, okay? Just don't do any writing for a second. Watch, okay? Here's what I'll see students do. I'll see students do this, okay? We just said that when you subtract, you divide. Here's what I'll see students do. They'll write the log base 3 of 6 over the log base 3 of 2. No, 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 no. Even though we're dividing, that's not the way you do it, okay? What you need to understand is those properties I gave you help you condense or expand out, okay? Either make it all one log or make it a whole bunch of logs, okay? We have 2 logs. We're going to condense it into 1 log. And let's get very basic. If you write it as 1 log, how many times do you get to write the word log? Only once. I wrote it twice here. Don't do that, okay? So write the log base 3. Do not do any calculating yet, okay? This is what Garrett was doing over and over and over, okay? I don't want you to do any computation yet. Of what? When we subtract, we? So tell me what to write. Don't do that. You went too far. Do what he was doing. 6 divided by 2. Then you can do what you said. Let's do 6 over 2. And then this seems log base 3 of what? 3. I would say go one step further, okay? What is the log base 3 of 3? And don't say times. What is it? 1. Why? All right, so the best answer is 1. But you know what it's going to click on the computer? That. They don't want you to simplify it as much as possible. They just simply want you to write it as 1 log. Okay, just 1 log. And then we did. Yes, you could go further. They don't want you to. Okay, so we have 6 log base 3 of 6 log base 3 of 2. 6 log base 3 of 2. Okay, they want you to rewrite this one, okay? So, are we going to use the product rule? What's that? What are you doing? The product? The power, right. Why are you using the power rule? Is there a power there?
No,
What do you see there?
6 times.
6 out front, so what can you do with that number up front? Move it to the back. So the log base 3 of 2 to the 6th power. All we did is moved it. Okay? Caitlin said earlier you can take that power, move it out front. If it's out front, you know what you can do? You move it in the back. Okay? Now, if you look on your computer, that's not one of the choices, okay? Because we can simplify that. They want you to actually simplify 2 to the 6th, and don't say 12, okay? 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. 16. 32. 64. Log base 3 of 64. And that doesn't simplify. Okay, a few more. Number 13. Okay, what we were doing was we're condensing. We had 2 logs, we wrote as 1 log. We used the power rule here. Now we have 1 log. They want you to write it as several logs, okay? So number 13, log base 3 of 4x. Okay, they want you to expand it. They want you to write it as more than 1 log, okay? Now, how many things are we taking the log of? I'm going to read it to you. By now, you should be able to read that. If you can't, listen carefully, okay? I know there's students out there. Every year I have students out there go, log 3 4x or log 3 to the 4x, something. No. After I say log, the very next word out of my mouth should be what? What is 3? It's a what? Base. Log base 3 of 4x. I'm going to say it another way. Listen real carefully. What's the log, base 3, of 4x? Okay. What am I taking the log of? 4x. I didn't ask you the base. I'm taking the log of what? 4x. 4x, okay? How many things is it? It's only one term, but 4x is made up of how many things? 2. What are they? 4 and x. Okay? So how many times do you think you're going to write the word log? Twice. If it was 4xy, you'd write it 3 times. Okay? So we're going to write log twice. And what does 4x mean? 4 plus x, 4 minus x, what? 4 times. And when you times, you what? Add. When you times, you add. So the log base 3 of what first? 4. What's the very next thing I'm going to write? Not times. When we times, we add. Then what am I going to write? Log base 3 of x. I'm going to be honest with you, these are kind of boring problems. They just want to make sure that you understand the rules so that when you're actually using them to solve equations later, you know how to do it, okay? Just expanding them, okay? 15, how many more are we going to go to today? Just a few more, not too many more. Number 15. Okay, log 10x to the 5th. Log 10x to the 5th. This is a tricky one, okay? This is a tricky one, okay? We're taking the log, first off, I don't see a base here. So it's base 10, which is a common log, okay? If you want to put the 10s in there, you can. Don't type them in though, the computer might mark you wrong if you put in the 10s, okay? All right, so here's what we're gonna do. Now, you gotta be careful on this one, okay? You might be tempted to move the 5 out front right now. You can't yet. We're gonna eventually move the 5 out front, but not yet. And the reason is, what's raised to the 5th power here? Only the x. If it was written like this, you can put the 5 out front because all of it's raised to the 5th, okay? So, 10x to the 5th means 10 times x to the 5th. What property or properties, as a hint there, are we going to use on this one? I already told you one of them. We use the power rule eventually. And what else? The product or the quotient?
Product.
We're timesing, it's product. And when you times, you add. So I'm going to write the log of what? Of 10. What's the very next thing I'm going to write? Plus the log of, okay, and I think you were already skipping a step. I heard you say something, you might be skipping a step, and that's okay. What can I do with this 5, though? Well, way over here?
No.
In front of this one. Is that what you were doing? Okay. All right. Now, this is what's frustrating about the computer. It's like a textbook. Textbooks make mistakes also. The computer's not perfect either, okay? If you type this in, it's going to mark you wrong. Back here, I said a better answer would have been 1. I would have simplified it. Well, this should be okay then, okay? But if you type it in, it's going to say you're wrong because you can simplify part of this. And we talked about this the other day, okay? And this is a real simple simplification, a real simple one. What's the log of 10? 1. Why?
Because there's a base 10. 10 to the 1 power.
You're not wrong. Is there a simpler way of, you're totally right. Is there a simpler way of saying the log of 10 is 1? What's the log of 1,000?
There's 1 0.
What's the log of 1,000?
3.
Why?
It's 3 zeros.
What's the log of 10?
1.
Why?
It's 1 0.
You're not wrong, but that's even easier. So log of 1, is that what you're saying? Is that what you said? The log of 1? Just 1. So the computer wants this. Okay? So when do you simplify it? I don't know. The computer sometimes it wants you to simplify it, sometimes it doesn't. Okay? On a written test, you don't need to worry about that. Okay. Let's do one more, then we'll call it a day. 15, is it? Is 15 the next one?
We just did 15.
We just did 15. How about we do 17? You don't want to do 15 again? It was a lot of fun. Okay, number 17, last one for today. If you're sitting here going, man, I don't know, this is kind of tough. It is kind of tough. Okay, we're going to spend several days on this, though. Natural log of x over 3y. Oops. Okay. So the natural log, which is base e, natural log, ln, of x over 3y. And this is not a mathematical term here, but hopefully you guys get it. I mean, there's only one term here, x over 3y, made up of how many things? X over 3y. How many things make that up? I mean, 4x, that was made up of 2 things, 4 and an x. X over 3y is made up of?
3.
What are they? X,
3,
3, and y. Okay. So, are we going to use the product rule, or the quotient rule, or the power rule, or a combination of some of them, or what? Quotient, why?
And
We're dividing. And
the product.
product, because we're
3 times.
timesing. Okay. So, let's do this. let's use the quotient rule first, okay? So the natural log of x, when we divide, we what? So what's the very next thing I'm gonna write? Minus the natural log of 3y. Okay. Now we gotta be careful here, okay? I'm gonna underline this right here. We're subtracting all of this, okay? So actually, rather than underline, I'm gonna put it in parentheses. We're subtracting all of that. When we times, we what? Add. So, natural log of x minus, in parentheses, how do I write the natural log of 3y? Again, the reason why I asked you how many things make this up, you said 3 things, 3x and y. So we're gonna write log 3 times, okay? So natural log of 3y, when we times, we add. So the natural log of 3 plus natural log of y. The computer might take this, it might, I don't know. Let's distribute the negative sign. So natural log of x, if I distribute it, what's natural log of 3 turn into? Negative ln 3, negative ln y. Oh, that's pretty cursive. Again, if you're sitting there going, man, this is confusing, I know it is. Okay? We're going to spend a minimum of 2 more days, probably 3 more days on this section. Okay? All right, we'll stop there for today.